All right, if I'm in charge of NASA, let me tell you, top of my list of places to go visit would be Europa. Europa is fascinating because it has the one thing that we look for above all else when we look for life. It has water. There's just tons and tons of evidence that this small moon of Jupiter, about the size of our moon, has liquid water under its icy crust. Take a look at this thing. Look at that icy, cracked shell. And that shell is cracked for the same reason that we just talked about Io in the last lecture, undergoing tidal stress. Europa undergoes tidal stress as well. That being tugged around mighty Jupiter, tugged and squeezed, that's the tidal stress part. And I just think of an ocean sloshing around in there underneath that ice. And I hope I live to see the day that we actually go there. There are all kinds of different ways you could get through that ice. You know, have a drill, maybe melt your way through, and then have a submersible, a submarine that goes around. Man, that would be so awesome to find out what's underneath that icy crust. Now, one reason we know good and well there's water there is because this surface has no craters, and there are practically no craters there. So every time something hits, it fills with water, refreezes, boom, fresh surface. So, and there I mentioned the tidal stress already. Now, when I say there's some water under the surface, there actually might be too much water. I mean, if that ocean is 60 miles deep, suddenly, I mean, we have enough trouble going to the bottom of a 5-6 mile deep ocean here on Earth. That could be a problem, actually, trying to go that deep in the ocean to find life. If that's true, if it was 60 miles deep, this moon would actually have more water than planet Earth because, of course, it'd be 10 times deeper, and it would be over the entire moon, versus ours is, 75% or so of the surface of the Earth. So pretty interesting stuff. Now, in a few minutes, we're going to watch part of a video where I'll show you these, what they call black smokers, these hydrothermal vents at the bottom of our oceans. And a lot of scientists now think that's how life got started here on our planet. And so that's what we envision for Europa. I don't think many scientists expect that there's going to be fish and squid and things swimming around in the water there when we get through. But maybe down on the ocean floor, you could have these hydrothermal vents where you have energy and you have water and you have carbon compounds and sulfur compounds, things that could create life possibly there. Very interesting stuff. We've seen giant chunks of ice actually shift around. And if that's not enough evidence for water, how about this? First of all, Europa is one of only 2 moons that has a magnetic field to begin with. And secondly, it is a variable magnetic field. Now, how is it changing? Because we think it is a saltwater ocean sloshing around in there, changing this magnetic field. So that's even more evidence. And then check this out. Very recently now, it appears that Europa is actually sending out plumes of water. Yeah. So we have geysers actually coming out, which is fantastic because now we don't even have to go drill through. We can actually study the water there and do a flyby just in case there's something actually in the plumes. That would be fantastic. So I believe the newest plan to go there is called JUICE. I think it's going to do a flyby of Europa and the other icy moon, Ganymede. So I'm not sure on a year on that yet. They've been talking about missions like this for a while, so anyway, I'm excited about it, but it's a little bit down the line. Let's take a look here at what Europa might look like. You see it, a metallic core. That's what generates that magnetic field. Lots of rocky sort of mantle there. And then here's the exciting part. You have this icy crust covering an ocean. I mean, it's there. There's an ocean there. There's no doubt. It's just a question of really how deep is that ocean. And obviously, is there any life there? This might help us out if there's some reservoirs like this lake that was possibly discovered back in 2011. We wouldn't have to dig down as far through the ice. Now, Ganymede is always going to be special because Ganymede has one claim to fame. It is the largest moon in our solar system. I have absolutely no doubt if you take Ganymede away from Jupiter, you would call it a planet immediately. It's actually larger than the planet Mercury. Yeah. And it has many planet-like features about it. I don't think it gets enough attention, actually. Europa kind of steals the show, but it very well may be that Ganymede has its own subsurface ocean. And in that case, maybe it would be easier to study it there. Maybe it's not as deep. Nobody thinks that the ocean there would be as deep. And then Callisto, sorry to say, is kind of the most boring of the 4 Galilean moons. It has one claim to fame. It has a whole lot of craters. It is the most heavily cratered object in the solar system. That's about all you can say. Now, both of these are not as dense as Io and Europa. That's a pretty low density for a solid object. 2,000 means there's a lot of ice. They're very, very icy objects out there. I already mentioned Ganymede's the largest moon. It has one kind of interesting big dark spot called Galileo Regio. And it has some weird streaks on it. Now, I've coined a term for this myself. I call them ice maria. Because on our moon, of course, we have dark regions where lava poured out that we call maria. On Ganymede, you have these sort of light-colored regions where it appears water may have poured out. Maybe there's an impact and water splashes out and refreezes and forms these light-colored streaks. So I call them ice maria. It's my own little term for it. Here's a picture of this crazy-looking surface, and it appears that at some point Ganymede actually had tectonic motion, which is pretty neat because Venus doesn't and Mars doesn't. And that's pretty neat that this moon has so many features that are very planet-like, including something, again, that Venus and Mars don't have, a magnetic field. Now, it happens to be a little stronger, I think, than Europa's magnetic field, which means this is the only moon in the entire solar system with what we can call a magnetosphere, meaning it has particles trapped around it, like a sea of particles trapped around it. The only moon in the solar system that can say that. So, pretty neat place. Pretty neat place. And again, could be a subsurface ocean there. Yeah, I hope I live to see the day that we explore Ganymede as well. Here's what it may look like. And again, we don't know for sure that there's liquid water there, but the fact that it's a variable magnetic field indicates that this region, maybe it is. Maybe it's kind of a slush, possibly. We're just not too sure. We need a lot more information. And then we get to little Callisto. Galileo missed this on his first night of looking through his telescope and at Jupiter on January 7th, 1610, because it's a little bit farther away than the others. It was outside of his field of view. And but that affects the moon, because being farther away means the tidal stress is much less, which means no internal heat. So you don't have water there. You don't have anything really going on at all. No magnetic field, anything like that. So basically, Callisto's been sitting there taking a beating for 4 billion years. It has 2 particularly large basins. One of them, I just like the name of it. I just throw it in the notes because it's cool. Valhalla, the sort of Viking, where Vikings go when they die. Valhalla, that's a pretty cool name for a really particularly large basin, a large crater. It has no internal differentiation. That simply means no layers. You don't have like core, mantle, crust. Instead, you just have a big mixture of rock and ice. Kind of boring. No internal heat, of course, as I mentioned, because there's no tidal stress. There's nothing there to produce heat. It's not big enough to have held on to the heat from when it formed. It's a pretty boring object, just to be truthful about it. So there's that super large Valhalla basin there. After about, I think it's about 300 kilometers in width, you start calling a crater a basin. And finally, I guess we have to mention the fact that Jupiter actually has a ring. Now, it's pretty bad when you've had a planet that's been viewed for over 300 years and nobody's seen that it has a ring until 1979. So you have to be really close to the planet to even see that it has just a little bitty ring of icy particles going around it. The only reason I think it's even worth mentioning, it's such a small, thin ring, is that means that every outer planet actually has a ring. So rings seem to be common. When you think of exoplanets that we're discovering, you can probably envision many of them then having rings. So, barely worth mentioning. I'm going to show part of this video. In class, we'll probably watch this whole video, but I want to show just the part here where they show those hydrothermal vents there. That's what they look like there on our ocean floors. Really superheats the water in that area. doesn't seem like a great place for life. I mean, when I was a little kid, scientists didn't think there could be life. And look at that, where there's no sunlight. There's no sunlight. And you have all of these animals that have adapted to that very, particular environment. It's pretty amazing stuff. It's pretty cool. And so that's what you could have in a place like Europa or Ganymede, for that matter. Great places to look for life. And that's really the name of the game, isn't it? We're trying to find life elsewhere to answer questions about us. Are we alone? Was this a freak of nature that there's life on Earth, or is life all over the place? Finding one other example would be one of the greatest discoveries of all time. At least it would let us know that life is common out there. So, but you know what? We won't know until we know. And that's why we keep building new spacecraft and spending the money to go out and explore and learn. Hey, thanks for listening.